Ever stop to think how your favorite music app just knows your playlist like instantly? Or how an airline keeps track of millions of flights and never ever loses your booking? Well, the magic behind all of that is a piece of tech we're going to break down today, the database management system. So let's pull back the curtain and take a look at the engine that runs our digital world. This quote right here just nails it. Look, we're drowning in information these days. But data without any kind of organization, it's just noise. It's a digital landfill that can actually hurt you more than it helps. So how do we get a handle on this mess? Okay, so first, let's just get a sense of the scale of the problem we're facing. We're not talking about a trickle of data. We're talking about a flood, a complete and total deluge of information that somehow needs to be wrangled into something useful. In the early days, we just used basic file systems. You can think of it like a giant digital filing cabinet, right? Folders inside of more folders. And that worked for a while, but it was super rigid. If you wanted to ask a new question, something simple like, hey, how many of our customers in Chicago bought this thing last month? You literally had to write a whole new, complicated program just to get an answer. It was slow, it was clunky, and it got overwhelmed fast. And this is where the big leap happens. Just look at the difference here. On the left, with the old file systems, everything is a pain. If the system crashes, poof, your data might be gone forever. Two people try to update the same file at once, total chaos. But look at the right. The database management system, or DBMS, solves all these problems. It gives you a language to ask pretty much any question you want. It's got backups for when things go wrong, and it handles tons of people using it all at once, no problem. It was so obviously a better way to do things. And that better way is the DBMS. You know, I love to think of it as a super smart, hyper-efficient digital librarian for all our information. It doesn't just store the books on a shelf. It knows exactly where everything is, who's allowed to check it out, and most importantly, how to keep it all safe and sound. So here's the textbook definition. A DBMS is basically the software that sits between your actual data and all the apps that need to use it. Its whole job, its entire reason for existing, is to make managing and using all that data simple, safe, and fast. And this is why there's such a game changer. A DBMS isn't just a box you dump data into. It's an active manager. It gives you these powerful ways to ask really complex questions, which we call queries. It's a bodyguard for your data, protecting it from crashes. It's an expert at multitasking, juggling access for thousands of users at the exact same time. And by doing all that heavy lifting, it makes it way easier for developers to build the apps we all use every day. And, you know, the core ideas we're talking about today aren't some new fad. They come from decades of serious computer science research, all captured in foundational textbooks like this one. This stuff is the bedrock of modern technology. So how do we actually tell our digital librarian what we want? Well, you've got to speak its language. To ask our database questions, we use a special kind of programming language. And the most famous one, the one you've probably heard of, is SQL. It stands for Structured Query Language, and it's pretty much the standard way to talk to most traditional databases. Now, I know what you're thinking. This looks like scary code, right? But it's actually not that bad. It's almost like plain English. This little command is just saying, select the names from my list of sailors where their rating is bigger than 8. See? It's a really precise, clear instruction that the database can understand and execute in a flash. Okay, so beyond just answering our questions, a DBMS does some really critical work behind the scenes. It's kind of like an unseen guardian, making sure our information stays safe, consistent, and reliable. These two things are absolutely huge. Concurrency control is like a traffic cop for your data. It's what stops two people from booking the very last seat on an airplane at the exact same millisecond. It makes sure only one request gets through at a time, avoiding total chaos. And recovery management, that's your safety net. It makes sure that if the power suddenly goes out, your bank transfer doesn't just vanish into thin air. It can be restored. To pull this off, a DBMS uses something called a transaction. Think about booking that flight again. It's a bunch of steps, right? If your payment fails on step 3, you definitely don't want the system to still think you have a seat reserved from step 2. A transaction wraps all those steps into one package and says it's all or nothing. If any single part fails, the whole thing gets rolled back, like it never even happened. It's absolutely crucial for keeping data accurate. Of course, a system this complex and important needs a human expert in charge. That person is the database administrator, or DBA. They're the ones responsible for designing the database, keeping it running smoothly, and making sure it's secure. They're the real-life digital librarians. But the world of data never, ever stands still. The challenges we face now, with things like big data and the massive scale of the internet, are pushing these systems to their absolute limits. So what we've been talking about is mostly the traditional relational database. It organizes data into really neat tables, kind of like a bunch of connected spreadsheets. It's amazing for structured stuff like your bank records. But for all the messy, unpredictable data of the modern web, think about social media feeds or sensor data from millions of devices, new types of databases have popped up. We often call them NoSQL databases, and they offer way more flexibility to handle all kinds of data at a massive, massive scale. So the big takeaway here is that this is a story that's still unfolding. As the kind of data we create changes, the tools we build to manage it have to change too. The basic ideas, safety, consistency, easy access, they all stick around. But how we get there is always evolving. Which leaves us with a pretty fascinating question for the future, doesn't it? We started with a simple filing cabinet, then we built this incredibly sophisticated librarian. But as we face an even bigger data explosion from AI, from virtual worlds, from everything, what's next? What new kind of digital librarian are we going to have to invent to make sense of it all?